Hi everyone, welcome to Skilled Inspirational Academy. As you see my screen, today's topic is Wireshark training. And a little bit background about myself. My name is Arjun. I'm working as a network engineer, and my responsibilities is to take care of the Cisco network appliances and wireless devices. I've been working in the same domain for past 10 years. So I'm carrying 10 years of experience in networking. So I would say the biggest takeaway of this class, what you would get once you finish this training, the biggest takeaway from this class is that you would understand Wireshark with more insights. And there are many people they still not aware of Wireshark, and Wireshark is very powerful network analysis tool. So by end of this training, you understand Wireshark with more insights about TCP and other most common used protocols. And also, by end of this class, you would be confident to confident, and you will be very skillful to filter out the packets in Wireshark, and you would get really a solid understanding of TCP. And also, you would able to troubleshoot your TCP and network issues once you finish this training. So that is the biggest takeaway from this class. So let's start this. Yeah. So for networking, the most common problem, if most of the time the network engineer they would be facing is the internet slowness issue. So all the team members, they'll be always barking about this problem. Either it could be a application issue, it can be a server issue, but it always, the network team will be blamed for the slowness internet connection, right? This is the most common issue we would know. So let's get started with this. So when you get a problem, generally what the network engineers, the conventional way of doing troubleshooting, what they do. So when the problem comes to the networking team, so they have access to, most commonly they use routers and switches. We all aware of it. So that's the appliances they use. And they say it is a layer 2 and layer 3 devices. As you know, this is OSI model. We say this is OSI model. And they mostly work on this layer 2 and layer 3. So the router is the appliance. It works on IP. So it is called layer 3 because it uses IP address for communication. Layer 2 is MAC address, and all your switches work on it. So I'm just giving a glimpse about this. So the maximum possibility what we have, the network engineer we have, is to check the physical connection first. Example, if you got 2 routers here, and if the physical connection is broken, or if you got any errors here, so you can check all this in your CLI. In the command line, you can see the errors are increasing, and so you can see your errors are increasing. Yeah, your errors, CRC errors. So this is possible with CLI. But what if there is a problem with the application? How do you prove? So here comes a debate between other team and the network team, right? So they say, okay, if I have checked everything, my network interface is clean, my utilization level is quite normal. It's not, the bandwidth is not choking. It is below 60% and there is no error. But how can I prove it is a network issue? So that is the biggest challenge we have. So how to deal this problem? So to understand that better, I'll give a glimpse about what is TCP IP. So what is the agenda of this class? So if there is a packet loss, how do I find? Okay, with all the availability, with the interface errors and all that, I have done all the checks, but still I couldn't figure out it's a problem with network. I'm a bit doubt about this. Maybe it could be a problem on my end, but my possibility is to check all this, but I did all this. But apart from that, how I can leverage this to the next level and to find how do I do a deep packet analysis and find out it is not a network problem, it is something with the application. How do I prove that? So here comes the challenge, right? So the most common problem when it comes to network performance is packet loss, right? If you see a packet loss, but how do I find it's a packet loss, and who is where the packet loss happens? Is it in the source or a destination? It can be either a source or destination. So how to diagnose and fix it? So before going to that, I'll want to give a glimpse about TCP and IP. So you all heard of it, but I'm not going too deep about TCP IP here, but I'm giving an idea of how TCP IP works here. So TCP, they say it's a transmission control protocol and it is reliable. Whereas with UDP, it is not like that. So why it is called as a reliable? So every packets it's received on the other end, it's going to send an acknowledgement for every single packet. So what is the advantage of this? If I miss any packet in the middle, so it's going to say, the destination is going to say that I didn't receive the packet, so you have to resend back. So that's called retransmission. So you have to retransmit the data because I haven't received it. And we all know that if you send a 1 MB of file and it is not the 1 MB file will not be sent it across as a one whole file, right? So that's chunks of data. So that's segmented into packets and it will be sent as a one by one. Packet 1, packet 2, packet 3 example. So if there is a problem with packet 3, it's going to acknowledge that I didn't receive packet 3. Can you send it back the packet 3? So this is a real advantage of TCP, whereas the UDP doesn't work. Once the connection is established, it's going to send the data continuously. It never bother about whether it's been sent successfully or it's a failure. It doesn't care about anything. It just continues to send this data. So your YouTube, most of the video streaming application, they use UDP. So this is the key difference between TCP and UDP. So here, if you see, if there is a computer, if you want to send a data, it sends us a small chunks before transfer. It's not the whole data. So with the help of TCP, what is the real advantage of TCP? The successful transfer is being acknowledged. But whereas in the physical network, this is not guaranteed, right? So if I have only access to my routers and switches, but how do I see all this? I cannot see all this information. So I can see only the interface errors and the physical problems I can figure out. But this is something, the segment level of analysis I cannot do with my appliances. So here comes the Wireshark. So how can I use a Wireshark to figure out all this and how I can filter all the protocols and I can do a deep packet analysis. So example here, if I send a packets with numbering, so does it mean that the packet delivery is successful? No, definitely not. So that's the reason the TCP is using the acknowledgement number and sequence number. This is again a glimpse, not too deep about this. So when we say TCP is a three-way handshake, whereas in UDP, it is not. So if you see, this is a three-way handshake. So this is a source, your PC. It's going to send a sync. So before your data transfer, the connection establishment should happen. So it means that if the PC sends a sync to the destination should respond back with sync acknowledgement. It says that, okay, I got your sync and an acknowledged. So for the sync acknowledgement, it's going to send an acknowledgement back again. So this is called three-way handshake. So it's fine. So we understood that the connection establishment should happen before your data transfer. That is a real advantage of TCP, whereas in UDP, it is not. So now we have gone through, how TCP, we got a basic understanding of how TCP works and what is three-way handshake and what is reliability and all that. So this is very basic. So what is sequence number and what is acknowledgement number? This is important. So whenever the conversation starts between source and destination, it's going to start with a sequence number. That's like, marking your packets. So every packet has its own sequence number. If you see here, this is a source. This is a random port number, right? Can you see this? This is a 4016. So you can find this is a random port generated by your Windows PC. And this is from the client. So I can say this is a client by looking into the source port numbers. And destination port is 80. And this is a server. How can I say it's a server? Because port 80 is HTTP, right? So this is a server. So it is trying to establish a connection. So this is a server back. See, now the source port is changed to 80. So earlier it was source is 4016 and destination is 80. This is source and this is destination. So here again, this is source. This becomes source because this is a server. And the destination port becomes 4016. This is your client. So this is a glimpse about how TCP sequence number and acknowledgement works. And now we go to the hands-on practical demonstration to find the TCP IP troubleshooting part. Okay, so let me open up this. So my objective here is to find only DNS. So there is a connection establishment happened. Example, you're trying to access google.com. So it sends a DNS request. This is for name resolution, right? And for the name resolution, it uses DNS. But in my packet capture, how do I find the DNS request alone? So I want to see how many DNS requests has been sent from my PC. So this is lab capture. So now this is the display filter. If you actually see this is the, let me maximize my screen. So this is the tool called Wireshark, and you can know about the version of it. This is version 4.0.3. And we'll see the list of options that's available. But what is the key options we have? Let me explain. So we don't want to bother about time, delta time. So we are just looking at the basic understanding of Wireshark here. So I did a capture and I've opened up the capture here. So here is a display filter where you can filter your protocols. So here I want to see DNS. So if I click DNS, I have to look at the displayed value here. So what is my displayed values? 606. So I got 606 DNS packets in my capture. Right? I can see here protocol is DNS. You are looking only DNS. If I delete this, if I remove this filter, I can see all the protocols, not only DNS. I can see TCP, HTTPS, and all other protocols. But I'm not interested in all that. I want to see only the DNS conversation that happened between my PC and to the destinations. So to do that, so here is an option is a display filter value. So here I have to type DNS, enter, that's it. So I get all the DNS. So how many DNS packets I got? I got 606 DNS packets here. So I got 606 DNS packets. So now I want to see, we all know about query, but this is again the basic understanding of query. So when you type google.com, what exactly happened in the background? So if you type google.com in your browser, I don't know about who is google.com. I don't know about anything. We all know this works only based on IP addressing, right? It works only based on IP addressing. So I don't know the IP address of google.com. This is unknown. So what it does, it sends a DNS request to the DNS server. So my PC points to Google DNS 8.8.8.8. We're all aware of this is root server. So my request goes to 8.8.8 and my PC is asking for who is google.com and what is an IP address. Example, I'm giving a private address here. It's 8.8.4.4. Example. So I got this address. So this is called as a query process. See, can you see this is all query process? It goes here. If you drill down this packet, you can see it's using DNS. This is a query. This is my source port. And this is destination port. So what is this? Is a DNS port number 53. And this is UDP. It is using UDP. So we'll get to know about all this. So if somebody is asking that your DNS is not working, you can do this. You can do a capture and you can see it is really happening or not. So from here, what is the query it says? So this is an host A record and this is www.google.com. So this is how you can filter out the DNS in Wireshark. So now we are moving to the next one. So I want to see how many queries has been done from my PC, how many DNS queries has been sent. To do that, I'm going to delete this filter. I'm going to apply this. So I got 981 DNS requests, queries has been sent. So all standard queries. If you see this, it goes to spxflow.com, youtube.com, cloudflare.net, Mozilla, and you can see all the domains. Wherever the query has been sent from your PC, you can drill down. And if you're interested on a specific query, you can go and see what really happened here. You get a query response back, then your DNS is success. If you're not getting it, then it is a problem. Something with your source or destination. So we'll get deep understanding about the DNS queries here. So what is the total number of DNS packets here? It's 981. So I got 981 queries. Sorry. So I got 981 queries has been sent from my PC. So if I am interested to filter out only the query which has been sent to google.com, how do I do that? To copy this, filter dns.query.name equal to the domain. For example, it can be youtube.com or whatever the domain you want to filter, you can do it. But this is the standard filter, that is dns.query equal and your domain name. Here, I want to filter out only google.com. I can see google.com. Only google.com here, not any other domains. So how many requests has been sent? 4 requests. So you got 9,851 packets, but the display value is 4. It means that only 4 queries has been sent for google.com because I filter out very specifically for google.com, the domain only for google.com. So the displayed value is 4. So total queries are 4. So 4 queries has been sent. Now, I got about 9,851 packets, but somebody is saying, okay, I got a problem with my TCP. But how can I figure out that? So to do that, you just go and type TCP in the display filter, and you will get only TCP. And we all know that TLS HTTPS is on top of TCP. That's why you can see TCP and TLS together. So how many TCP packets I got here? So out of 9,851 packets, the only TCP packets are 7,988. So 7,988 packets, only TCP. So to find how many UDP packets, I'm not interested on any other packets, and how do I find UDP? So this shows only UDP. Because here it shows MDNS uses UDP. We have seen that. The user datagram protocol, it uses port number 53. So you see MDNS along with that, because whatever the protocols it uses DNS, it's going to show up here. So out of 9,851 packets, I got only 1,752 packets. Only DNS. Sorry, only UDP. So in the same way, we know about ICMP, right? So ICMP, let me give you a glimpse about ICMP. So this is my source, and this is my destination. So the ICMP will send actually the 4 consecutive packets to test the connection. This is called ICMP request. ICMP response. So ICMP request will be sent by the source, and this is sent by the destination. If for my ICMP request, if I get an ICMP response, then the connection, then I have a connection between source and destination. And if I am not getting ICMP response, then there is something problem with my destination. But how do I find that in Wireshark? You have to go erase this filter, and I have to type ICMP. Can you see this? This is ping request. This is all requests sent from the source. This is my IP address, 192.168.0.38. This is my IP. My PC is trying to communicate with this destination. This is ping request. And if you see the ping reply, this is the destination. It is sending a reply back to my source. This is ping reply. So from this, you can figure out, see, this is all port unreachable, right? So if I send from my PC, I'm trying to communicate to this destination. It says destination unreachable, port unreachable. So it means that there is some problem with my destination. You can see multiple destinations, all public IP addresses, it's all destination unreachable. So from this, I can figure out this too has communication for sure, because I see ping request and ping reply back, whereas I cannot see the ping reply from the destination, from the public IP. See, my source is sending packet, but I am not reaching the destination, port unreachable. So it says there's something problem with all these IP address. This is all destination unreachable. So you can say, now I don't have any problem with my network. It is something problem with the destination. So you will get the solid understanding. You have a solid proof that your part is fine. You don't see any problem from the network standpoint. It's something problem with the destination. You can prove that.